Program control in computer organization and architecture. Program control instructions black circle. It is sometimes convenient to supplement the ALU circuit in the CPU with a status register where status bit conditions be stored for further analysis. Status bits are also called condition code bits or flag bits. Figure 5.3 shows the block diagram of an 8-bit ALU with a 4-bit status register. The 4 status bits are symbolized by C, S, Z, and V. The bits are set or cleared as a result of an operation performed in the ALU. 1. Bit C, carry, is set to 1 if the end carry C8 is 1. It is cleared to O if the carry is O. 2. Bit S, sign, is set to 1 if the highest order bit F7 is 1. It is set to O if the bit is O. 3. Bit
Z, 0, is set to 1 if the output of the ALU contains all O's. It is cleared to O otherwise. In other words, Z equals 1 if the output is 0 and Z equals 0 if the output is not 0. 4. Bit V, overflow, is set to 1 if the exclusives OR of the last 2 carries is equal to 1, and cleared to O otherwise. This is the condition for an overflow when negative numbers are in 2's complement. For the 8-bit ALU, V equals 1 if the output is greater than plus 127 or less than minus 128. The status bits can be checked after an ALU operation to determine certain relationships that exist between the vales of A and B. If bit V is set after the addition of 2 signed numbers, it indicates an overflow condition. If Z is set after an exclusive OR operation, it indicates that A equals B. A single bit in A can be checked to determine if it is O or 1 by masking all bits except the bit in question and then checking the Z status bit. CMP and TST instructions do not retain their results of operations, and, respectively. They only set or clear certain flags. Subroutine call and return call. Subroutine jump to subroutine branch to subroutine branch and save return address. Program interrupt. There are 3 major types of interrupts that cause a break in the normal execution of a program. They can be classified as 1. External interrupts. 2. Internal interrupts. 3. Software interrupts. 1. External interrupts. External interrupts come from input-output I/O devices, from a timing device, from a circuit monitoring the power supply, or from any other external source. 2. Internal interrupts. Internal interrupts arise from illegal or erroneous use of an instruction or data. Internal interrupts are also called traps. 3. Software interrupts. A software interrupt is a special call instruction that behaves like an interrupt rather than a subroutine call. It can be used by the programmer to initiate an interrupt procedure at any desired point in the program. Thank you.